All right. So what I thought I'd just discuss a little bit today is really this concept of motivation and research. Really, the ideas relate to how does motivation and research sort of work together to sort of produce a situation that allows research to go forward in a reasonable manner. And so the real questions are how to do research and how to motivate research. And these are very personal views, and I'm going to use some personal data to show you some experiences that I've had related to this, both as a researcher and as a sort of a team leader sort of idea. So the questions I have really to try to address are, what are the challenges for researchers like yourselves and research teams related to the whole idea of research? What about the research career? What is important about that? And how does that come into the story? Can researchers really be motivated? And what are the important factors to try to motivate researchers? So the first thing that one has to consider is that it doesn't really matter where you are as far as research is concerned, whether you're applying for a CIHR or applying for an FRSQ or any of the other applications that you may be involved with, or larger applications from insurance companies or other types of institutions that may be funding various types of research. What basically is happening now is that funding is becoming more and more competitive. It's certainly much more competitive than it was when I started. And funding is really based on good applications that really involve what could be considered to be very high quality research. So if you think about it, what does an agency want to hear about? Well, it wants to hear about the fact that you have a good hypothesis or hypotheses, that you have specific objectives, that you're original in some way, the research you're doing is really original, and you actually can do the research. It actually can be done. And then what these organizations do, and we'll look into a little bit more in depth in the next slides, is they sort of want to know from your laboratory and the laboratory you're involved with, how many papers are being produced? What are the quality of those papers? How about the impact factor of the journals that these particular papers are published in? And we'll talk about that a little bit. How about the citation index? What does that mean? And what is the citation index of the individuals who are applying? And a concept called the H index. And another issue is there a relationship between your group and other groups in other places, international or national, or are you working together related to these sort of issues? So if you sort of think about good research, what does it really mean? Well, in medicine, what you really want to do is do fundamental studies that lead to some type of translational research. Well, what does that mean? Well, it means that at some point you can test the idea on a human condition or a human issue. In our particular case, let's say is surgery and surgical education, but you have to have something that you can actually get to related to a concept that might help humans. The second is if you're just outlining a phenomenon like this happens, and you don't understand or don't have any idea about the mechanism, that doesn't seem to be very competitive at the present time for high impact journals. And if you think, well, how are you going to deal with mechanism? Well, dealing with mechanism, what you'd like to do is do different levels and involve different types of experimental technologies. For example, let's say in what we do, I mean, clearly we do virtual reality, we do simulation. And then if you add on top of that artificial intelligence or add on top of that EEG or add on top of that some other type of technology, it tends to fill out the concept a little bit more and get more people interested and involved in that particular idea at multiple levels. And also what you really have to begin to do is use the resources you have in the actual lab and around the lab and try to increase the interactions you have between people in the actual group. And that is a key factor, because the more interactions you have within a group, the more people work together, the greater possibility is that you'll have some success, have a higher impact type of paper, and also the potential of getting the funding for you as a CIHR applicant, FRC applicant, or whatever application you want to be involved with from that aspect of it. So let's say you're on a research committee, which I've been on a number of them. Well, what do they look at? For some reason, they picked the idea that they're very interested in how many papers have you as a person published in the last 5 years. Now, that's not so important for people at a beginning level, but as soon as you start out, they're very, very interested in, for example, if you're doing a master's, if you're doing a PhD, how many papers have come out of that particular time period. And the second thing they immediately do is you just go on Google Scholar or the ISI Web of Science, and you figure out how many citations do you have. So for example, if you look at the number of citations, are these citations going up in the last number of years? Have they gone up in the last number of years and now are coming down? What does it look like? What does your citation index really look like? And I'll talk to you a little bit more about that. And the second thing is they talk about is what's called the H index. So let's go that way. So what is an H index? Well, basically it was developed from the University of London, but really it's an index which really attempts to measure both the productivity and the impact of a published work of a scientist or scholar. In other words, it's trying to figure out how many papers have you written, and what is the impact of those particular papers. And so every university is different, but it's felt that you have to have an H index, and 10 to 20 or probably more to have any type of a junior faculty position nowadays, and 30 to 50 to have a full-time position. So the numbers are going up, and I'll discuss how that works from that aspect of it as far as what this H index really involves. So the first thing you have to do, if you, for example, put my name in Google Scholar, and the first thing that comes up is you'll see data like this. And the first thing that going back here, one thing that you immediately see is that here are the top cited papers related to my productivity. And if you look closely, it's interesting. This particular paper was written in 1980, which was associated with my PhD, and has 1,000 citations, and actually is cited almost every week or two. So even though it's 40 years old, that particular paper continues to be cited. Why? Because it was an attempt to deal with a mechanism of free radicals. This is my second most highly cited paper, again, is from the time period that I did my PhD, as is the third. So the first thing you find out is that most of your citations, at least in my case, have come from the time period that you're most involved with the research. In other words, when you're most concerned with the research, when you're putting all your efforts into research, you can be, at least in my case, more productive. Obviously, when you get into have all kinds of other responsibilities, patient responsibilities, family responsibilities, there tend to be other issues that occur. The second thing you can see from these situations is if you develop a mechanism. This happened to be developing of a spheroid preparation mechanism that we developed in the lab, and it's used by many different individuals. And then you can see, for example, neurotouch is also relatively highly cited from that point of view. But what's interesting here is that when you look for HFAT, the H index, this is only one paper, even though you have 1,000 citations from that paper, it's only one. So again, when you look at on Google Scholar and look at me, what you have is you see that they give you the full number of citations. So I have 10,248 citations over my lifetime. That's not quite all of them because it only goes back to 1980, but it's pretty close. My H index is 55. What that means that I have 55 papers that have at least 55 citations. So it's 55 papers with at least 55 citations. And therefore, you'll go up to 56 when you have another paper that has 56 citations. So that is sort of what the H index is. The second thing, if you look at the last 5 years, for example, in the last 5 years, I've had about, let's say, 25% of my total citations have been in the last 5 years, which is relatively high. And it probably suggests that the citations are going up. And I'll show you that information. But the other thing that's interesting, in the last 5 years, there's been 28 papers that have 28 citations already. So you can see that for whatever reason, we're a little bit more productive in the last number of years than we have been before. The other thing is, when you look at the last 5 years, you can see that basically all our citations in the last 5 years, and there's many more, are pretty well all related to the issue of artificial intelligence, machine learning, and that aspect. That seems to be a much more hotter topic than some of the other areas that I was involved with before. And the second thing is you have to be careful. And the reason you have to be careful is of citation indexes and other things. And this week, every week I get a note from RescachGate, and it tells me what's happened this week to my productivity. And what's interesting, every week, a paper I wrote in 1998 is the highest number of reads, the highest number of full text reads. And if you look at the total number of full text reads, it's almost 14,000. So 14,000 times that particular paper has been read. It's actually been cited only about 45 times. So here you have a situation where you have a paper that isn't cited very much, but large numbers of people are reading it. And you can see how this can happen again. Remember how I told you about that other paper that's associated with the model? And here you have again, it has almost 4,000 reads and full text reads from that point of view. And if you look down here, NeuroTouch has about 1,000. But what's interesting here, artificial intelligence, paper we produced in 2019, this was Alex's paper related to best practices. It already has 568. So again, you can see that this particular paper, and there are others if you go down, it's going to have a lot of reads because it happens to be an area that happens to be interesting at this particular point in time. So you not only have the idea of a citation index, an H index, but also this idea of how many people are actually reading your work. That's an important aspect of it too. The other thing I can tell you, and it's something that you don't want to hear, is science is merciless, absolutely merciless, which means if you are increasing your productivity, then what happens is you get more funding, your group gets bigger, you get more citations, it continues to grow. However, if you're doing the opposite, you don't get as many citations and the number of papers out, you begin to slow down, and we'll go through that in a second. What happens is that funding decreases, the group has to decrease in size, and then what you have to deal with is what are you going to be? What part of the spiral are you going to be involved with? Are you going to be in the spiral where we're going up, or we're coming down from that aspect of it? So the other thing is no group, no matter who you are, can continue to grow forever and ever and ever and ever. You know, to continue to have more and more citations forever. Probably there's a time period where you're going to begin to level off. And the level off is probably okay, but if you're starting to go down, it suggests that you're not having the same impact you were having before. So what can you do about this situation? Well, what you can do is you have to change. If this is what is happening to you, you have to consider what am I doing wrong? How do I improve the situation? So if you don't want to have this happen to you, where your number of citations goes basically to almost zero over a period of time, you actually have to change what you're doing, have to change the type of research or the focus that you have, bring new individuals into the group and try to sort of build the group in such a way that it continues to improve related to the number of individuals that are able to produce papers and produce them at a high level from that aspect of it. So if you look at what happened with me personally, and I'm just going back to 1990 here, you can see here in 1990, really 1990 to 2000, I was head of clinical neurological sciences, neurosurgery at a major trauma hospital. I also was involved in doing the pediatric neurosurgery for Southwestern Ontario when I was at the University of Western Ontario. And although I kept my lab running, I wasn't able to actually spend as much time in the lab and focus as much of my energy as I would have liked to at that particular point in time. And although my numbers stayed up, they did not increase. Rather remarkably, in 2002, I produced 10 papers, which is sort of interesting. But in 2000, I moved from the University of Western Ontario to McGill. And although these numbers are part of these ones, basically what's happened here, as soon as I came to McGill, things changed. Why did they change? Well, there were more interactions to be involved with. There were other researchers that I could work with, and therefore the citations began to go up, as you can see here. And then you see them leveling off a little bit more. Why are they leveling off? Well, I'm very, very busy as a neurosurgeon. I'm getting referrals from all over the world, and so again, it's hard to keep the activity going in that type of situation. But then basically we open the simulation center about that time, and you can see again that the numbers are going up. Now the question is, will they continue to go up like this, or do we level off again? And if we level off, what do we do then? How do we get another jump to go up related to the research from that aspect? So those are the types of things that you can see over a period of time, things that influence you and prevent you from being more and more productive, and other things that help you become more and more productive. So if you want to, avoid ending up with this reduced citation index, you basically have to increase your productivity, increase the quality of your productivity. You really have to start being much more interdisciplinary. You have to add other issues. So, for example, you can suggest that in the first 4 or 5 years of the virtual reality work that we did, we were able to get a certain amount of work done. And you can see, for example, developing the neurotouch and some of the other. But as soon as we added things like artificial intelligence and some of these other sort of aspects of the research, it sort of helped us to be more productive. And you basically have to interact with a number of individuals if you're going to continue to be interactive over a long period of time. So basically what you want to do is get more interactions, which will benefit your project, whatever the project has to be, and will increase the scientific quality. And then you'll be more competitive. You'll be more competitive to get the research, to get various types of CIHI grants, FRSQ grants, et cetera, from that aspect of it. So basically the interaction is the important part to keep this going from that point of view. Now, how about a career path? All right, let's say what's going to happen? Well, if you're a university student or a medical student, I mean, clearly what you're thinking about is, I've got to get good grades, I've got to, move on, I've got to do better from that aspect and try to get to a position where I have options. If you're, for example, an MSc student, you want to finalize your MSc, but then you have to really question that you have to ask yourself, what do I do next? Do I stop at an MSc, go into, let's say, pharmaceutical research or whatever types of research you might be interested in, or do I go on? Then if you're a PhD student, you start thinking, have I generated enough papers? Will I be competitive for a fellowship position? What do I do next after that? If you're in a fellowship position, you begin to ask yourself, well, do I have enough? Have I done enough to really fulfill all my scientific goals? Will I get a permanent position? Will I be able to establish my own sort of research group? And then early research positions, you have to sort of, can I do high quality research? Am I going to get recognition? Am I going to be able to move in this spiral to go up, or what's going to happen to me from that point of view? And then when you're in your late situation, let's say like I am, what is going to be left of all the things that you've done? I mean, is there an overall contribution that you've actually made from that point of view? So if you think about it, of let's say 100,000 students that come to university, probably one gets to this point. Very, very small numbers get from here all the way up to here. And it's sort of the same as what occurs, for example, in hockey or anything else. To be able to continue to go all the way up, you need something very special. And basically what you need is motivation. You have to be motivated to continue to work at things, even when it's really hard. Or in my life, I've gone through 3 recessions. Every time there's a recession, the first thing the government does is cut off funding to research. And you have to sort of survive that particular aspect from what's going to go on. So if you think about it here, if you think about a career path in surgery, or a career path in any type of research, you have to start thinking to yourself, well, how do I motivate myself to get there? Because you're really talking about motivating yourself. So you can think about it, am I critical? Do I have some talent for research? Am I able to interact with people in a reasonable way? Am I able to show that I'm ambitious and I'm flexible? And you have to be sort of stubborn to be a researcher. Even though the mistakes, you do all this work and you get nothing for it, you have to go on and try it again or try some variation. And you have to continue to try to be creative and develop new areas. And probably the best new areas to develop are between 2 areas. For example, between surgery and artificial intelligence, between virtual reality and surgery. Some interaction between 2 groups is the important area to try to find a little niche for yourself, to be able to do something that's new. And again, the idea that you have to be motivated to get to these particular areas. Now, to have inner motivation, you have to first have interest. You really need to be interested in what you're doing. And the second thing is you have to get a fair amount of satisfaction from doing the research. Even if things aren't going well, you have to be satisfied that you're moving ahead. And it can't be a hobby. I can't tell you how many surgeons, how many researchers I've seen in my life who think that research is a hobby. They can do a little bit of research on the side. That's not what really happens in the real world. You don't do something on the side. You have to be committed to do that particular thing. The other thing is, I personally think it's difficult and probably impossible for someone like me to create an inner motivation in a person. If that person is unmotivated, doesn't want to put the effort into something, it's extremely hard, no matter what you do to motivate that particular individual. So I can provide external motivation. I can buy some more funding. I can provide money to go, for example, to meetings in the time period when we didn't have COVID. I think an important thing is authorship. There are some individuals, research heads, who believe that they should be the first person on all their papers, for example. Obviously, having the person who does most of the work being the first author is a very important aspect. And also the corresponding author is also an important thing, because if you're the corresponding author, the people who are interested may correspond with you. And again, that's an important thing that's associated with authorship. Salary you can help a little bit with that, but most salaries are somewhat fixed nowadays. And the possibility for some type of advancement in the group if the group is large enough. But the bottom line, you can provide inner, sort of external motivation, but it's very difficult to provide inner motivation in a person who is not motivated from that aspect of it. So what do you want to do? Well, you want to find individuals that you want to work with that have this inner motivation, and you have to have this inner motivation to be able to sort of move from the university student all the way through to having a rich and fulfilling career. And you have to try to see if you can provide such individuals with external motivation. If an individual has internal motivation, can you use those resources to help them related to getting various presentations, various sort of authorships, other things that help them on their career path. So one of the problems related to a research leader is I think sometimes there's a tendency that you want to have more control of what's going on. You don't want to have the individuals under you do their own thing because you have your idea of how it's going to go forward. My PhD supervisor always said that the best day in his life was when his PhD students would come in and bang on the table and tell him that he's absolutely wrong, and this is the reason that you're wrong, and can prove it to him. Because if that happened, then basically that particular individual is moving into another stage. But if you don't allow individuals to do that, you don't allow to challenge you and to make you think about what you're doing, you have a tendency to lose talented individuals because they'll go to environments in which this occurs. And then you have to really show generosity and this external motivation that I've talked about. And also, you basically have to provide that talented person who works in the lab, this is related mostly to laboratory technicians and other people like that, who are very, very important parts of the research team, but are not the individuals that are writing the papers, etc. You have to be able to continue to have them feel that they're a very, very important aspect of a research program, so that they also stay and are motivated to continue to do hard work in the laboratory, which sometimes is very difficult because many of these individuals do some of the more tedious, repetitive types of positions and jobs. So what are my conclusions? Well, first, I think the most important thing is you really have to have interactions and collaboration with a whole bunch of different people within a group and among groups if you're going to be successful. The thing I think it's very difficult for people to understand is that everybody in the lab benefits from each person's success in that lab. So no matter how you think about it, everybody who has success in the lab helps make your success more possible. So the issue of jealousy and other things like this are really not a really important thing that should be involved in a laboratory situation. It should be more the idea that to help everybody reach whatever potential they can reach doing the particular research or other aspects that they're involved in doing. And then you really have to work with finding the right individuals for you to be involved with, and individuals that continue to motivate you and can keep you going. And try to find the best working environments that you possibly can. Some labs are very, let me put it this way, you can go into some labs that are completely clean, there's nothing on any of the benches, everything is just spot clean. That's probably not the best type of lab you want to be in. You want to have a lab that's just bustling with all kinds of equipment around, with all kinds of things going on all the time. In that type of situation, you can learn quicker, you can adapt quicker, you can get more interaction done. And the other thing is probably try to be respectful to all the individuals that are in the lab, however they interact with you. Because the more respect you have within a lab group, the more there is a possibility that that particular lab group is going to do well. There's no guarantee in any experiment that it will go well. But if everybody respects the fact that everybody's trying their best to do their best job they possibly can with the abilities they have, then that's what we have to go for from that point of view. And if people don't have a particular skill, then finding the people who do have that skill, who can teach it to you or they work with you on it, I think is one of the ways to go ahead in these types of situations.